Okay, so now that we've covered the substitution and the elimination method for solving systems of equations, now we want to apply those to some real world system problems. So here are some examples that I'm going to work through with you. So, number one, two musicals had very long runs on Broadway. During their runs, there were 572 fewer performances of musical A than of musical B. The two shows had a total of 10,908 performances. So, part A asks you to write a system of equations to represent this scenario and define your variables. So, defining your variables just means to tell me what your variables are going to be and what they represent in the problem. You can use X and Y if you want to on every single problem, as long as you tell me what X and Y stand for. Or you can use variables that represent things in the problem. Like, for example, in this problem, since we're talking about musical A and musical B, I'm going to use A to represent musical A and musical B. So A is going to be the number of performances of musical A, and B is going to be the number of performances of musical B. It doesn't really matter what you pick as long as you define them. And then you want to set up a system of equations that you're going to eventually solve. So this sentence right here, the two shows had a total of 10,908 performances. When you see the word total, that normally means you're adding. So we know that if we add these two variables together, we should get a total of 10,908. So there's one of your equations. A plus B has to add up to be 10,908. The other equation is a little bit more difficult. During their runs, there were 572 fewer performances of musical A than of musical B. So musical A is 572 fewer than musical B, which means we would have to take musical B and subtract 572 to put it at the same level as musical A. This equation here is often written backwards. So just make sure you read it very carefully. Another way to write it would be to put the 572 on the other side with the A, but write it as addition. So you could write it as A plus 572 equals B, and that would be correct also. So there is your system of equations. And then part B wants you to actually solve them and figure out how many performances there were of each show. And so this is up to you as far as would you rather solve them with substitution or with elimination. So we've talked about how with substitution, you want a variable by itself, and you have that. You have A by itself right here, so you could definitely do substitution. And with elimination, we've talked about how you want your variables lined up, and you want opposites. We also could easily have that. If you just take this B and subtract it to the other side of the equal sign, you would have a negative B. And so you would have your variables lined up and you would also have opposites. So really either method is about as easy here as the other. So it doesn't really matter, it's personal preference. I'm just going to do a substitution. So since we know that A equals B minus 572, I'm going to put B minus 572 in the A spot in this equation. So B minus 572 is going here. And then we have plus B equals 10,908. Then we're going to combine like terms. So we have 2B minus 572 equals 10,908. We can add the 572 over. And then have 2B equals 10,908 divided by 2. So B is 5,740. Okay, and then we need to find A. So since we're doing the substitution method, you can always take your first answer and plug it into that first equation you use to find the other variable. 5,740 minus 572. So A is going to give you 5,168. So this is musical B. and this is musical A. Okay, so just be very careful on that one as far as how you set up this equation right here. That subtraction can be tricky as far as maybe writing these in the wrong order or putting the 572 on the wrong side. Okay, number 2. You're running a concession stand at a basketball game. You're selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold a total of 87 hot dogs and sodas combined. Write a system of equations to represent the scenario and define your variables. Okay, so you are selling hot dogs and sodas, so we can say that H is going to be the number of hot dogs, and we can let S be the number of sodas. Be careful using S's because sometimes they can turn into 5s, so just be careful with that. This last sentence right here tells us one of our equations. You sold a total of 87 hot dogs and sodas combined. Again, we've got that word total, which tells us we're adding. So hot dogs plus sodas combined, total of 87 items. Okay, now our other equation comes from the money that we made. So each hot dog was $1.50, each soda was 50 cents, and we made this much money. So for every hot dog we sold, we made $1.50, so we can put 1.5 per hot dog. And then we also made 50 cents, so 0.5 per soda. And then together, a total of 78.50, 78.5. So there's your system. And to me, this looks like it's set up perfectly for elimination because everything is lined up in order. What I would probably do to get opposites, you can multiply this 0.5 by -2, and you would have a -1 down here, and then you would have opposites on your S's. So I would probably do that. So I'm going to take the top equation and leave it the same. H plus S equals 87. I'm going to take that bottom equation and multiply by -2. So -2 is going to everything in that bottom equation. Okay, so -2 times 1.5 is going to give you -3H. -2 times 0.5 is going to give you -1S. And then -2 times 78.5 is going to give you -157. And then you're ready to add those. Okay, so when you add your H's, you're going to get -2H. S's are going to eliminate. When you add your constants, you're going to get -70. Then you're going to solve this by dividing by 2. Or sorry, -2. So for hot dogs, we're going to get 35. 35 hot dogs. And then we need to plug that back in to get sodas. So just take this equation right here, plug it back in. 35 in the H spot plus S equals 87. Subtract that 35 over. Cancels out. So we get 52 for sodas. So we sold 35 hot dogs and 52 sodas. You could have also solved this problem with substitution if you wanted to get either this H or this S by itself to begin with, and then you could have done substitution. Remember, substitution works best when one of your variables has a coefficient of 1, which both those do. Okay. Number 3. Drew is 3 years older than Callie. In 4 years, the sum of their ages will be 37. So write a system of equations and define your variables. So we'll let D be Drew's age, and we'll let C be Callie's age. Okay, so the first sentence says Drew is 3 years older than Callie. It's set up perfectly for an equation. When you see that word is, that means equals. So Drew equals 3 years older than Callie, 3 years older than Callie, 3 plus Callie. And then the second sentence, in 4 years, the sum of their ages will be 37. Well, sum tells us we're going to add, so we know we're going to add their ages together, but we're going to add their ages together in 4 years. So in 4 years, they'll both have gained 4 years on their age. So we need to take Drew's age now plus 4 years. And then we need to take Callie's age now plus 4 years and add them together, and that will be 37. Okay, so Drew's age 4 years from now and Callie's age 4 years from now, and then the sum of those two should be 37. Okay, so we do have some like terms we can combine here to make our system look a little bit better. I'm going to go ahead and bring over that first equation, D equals 3 plus C. And this second equation, let's combine some like terms. The 4 and the 4 would be 8, so we have D plus C plus 8 equals 37. And then if you wanted to, you could subtract that 8 on over and get the constant on the other side. So that would be D plus C equals 29. So D plus C equals 29. So there's your system. Okay, and then for part B, calculate how old Drew is now by solving your system. All right, so the way this is set up, I'm going to do substitution because I already have D by itself. So if I know that Drew is 3 plus Callie, I'm going to put 3 plus C in this D spot right here. So 3 plus C is going in the D spot, plus C again, equals 29. Okay, so I have 3 plus 2C equals 29. I'm going to subtract my 3 over, so I have 2C equals 26. Divide by 2. Callie is 13. Okay, but I didn't want to know how old Callie is. The question is, calculate how old Drew is. So I need to plug that C back in and figure out Drew's age. So go back up here to this equation. Drew is 3 plus Callie. So Drew is 3 plus 13. So Drew is 16. 16 years old is the answer that we want. Okay, and the last one, number 4. There are two numbers such that their sum is 84 and their difference is 6. Okay, so we're just doing two numbers here. I don't really have anything in the problem that would tell me to use a particular letter, so I'm just going to use X and Y. So X is going to be our first number, and Y is going to be our second number. The two numbers have a sum of 84. Sum tells us we add, and a difference of 6. Difference tells us we subtract. This one's very easy to set up. We're going to add our numbers and get 84. We're going to subtract our numbers and get 6. There is our system. Okay, this one's very clear that I want to use elimination. We have our variables lined up perfectly, and we already have opposites right here on our y's. Okay, so let me just write them again down here. Add those so I can do elimination. My y's eliminate. I have 2x, and then if I add my 84 and my 6, I get 90, and then I divide it by 2. X is 45. Okay, so there's one of my numbers. Now I need my other number. Use any one of your equations to find the other number. So put 45 in the X spot. I'm just using the top equation. 45 plus Y equals 84. Subtract the 45 over. So y is going to be 39. So my two numbers are 45 and 39. And I'm sorry you couldn't see the bottom of the paper, but those are our two answers.